Alright gang, this is section 4.4. It's the final section in chapter 4, most likely, at least these days it is, in the year 2018. And it's called Writing Linear Equations, and it's going to revolve around what's called point-slope form. And here's what point-slope form looks like. Okay? I guess you can contrast this with a form we've already been working with a lot, slope-intercept form. Remember, slope-intercept form was this. Okay? This was called slope-intercept form. And we used this to graph lines very quickly and easily, because when you have an equation given to you in this form, you can see the slope right here, and you can see the y-intercept right there. You can see both of those things right in the equation. And you can take those two things and you can graph your line. But you could also use this form to come up with an equation that's not given to you. Like if you were given info, or if you were shown the graph of a line and the directive was, hey, what is the equation of this line that you're looking at or that I'm describing? Like, for example, if you were just blatantly told for free that, hey, there's this line and it's got a slope of 2 and a y-intercept of -3. What's the equation? Well, if these are the ingredients you're given, if those are the details that you're given, M and B, then you're just going to throw those numbers into this form and you'll have an equation just like that. But you're not always given these exact, details about your line. You might be given instead the slope and a random point that is not your y-intercept. So anyway, we just have this other form, right? And both of these forms, all right, both of these forms are on my wall these days. 2 of my wall tattoos. And also, both of these forms are going to be found on your Keystone exam formula sheet. Eventually you're going to take the Keystone exam. That exam is obviously still around in these days. And when you eventually take that test, you're going to be given a formula sheet. And both of these equation forms, linear equation forms, are going to be on that formula sheet as well as on my wall. So here's the deal with point slope form. Like I already sort of hinted, right? If you have a slope and a point, you can plug those in to this formula. Now obviously the M here is going to be your slope, but a point would be an x-coordinate and a y-coordinate, but it's actually x1 comma y1. So y1 would be the y-coordinate of, a point given, And x sub 1 would be the x-coordinate. Of that point. Okay? So you would take from the same point the x-coordinate and the y-coordinate, and you could plug them in for x sub 1 and y sub 1. It's very important to understand that you're not going to plug in anything for the x variable and the y variable. Remember, for an equation to be a linear equation, there's got to be like an x and a y in there. Okay? Just like we've been doing lately, if you knew the slope and the y-intercept, you would plug them in for m and b. You wouldn't plug in anything for the x and the y. You need to have a open-ended x variable and y variable to make your equation a linear equation at all. So just down here, you're not going to plug in anything for the regular x variable and the regular y variable. You know, you take the coordinates of some point and you plug them in for x1 and y1. And of course, you plug in the slope for the m. All right? So let's see this in action. First example is, it's good to kind of throw one of these in here. Notice that they're giving us m and they're giving us b. And so we want to find the equation of that line. Well, considering what they gave us is m and b, I'm going to choose this form of an equation. And then since they blatantly told me that m is this and b is that, I can just throw them in to the proper spots. So b is -2, so just write -2. And just like that, I'm done. Okay? M in there, b in there. Yeah, I mean, it really is that simple. You know, if they gave you the perfect ingredients for this equation formula, then that's the formula you pick. Likewise, in example number 2, in problem number 2, yes, they're giving me m, but that's not b, that's not the y-intercept, that's some other sort of random point. And so, since what they're giving me is a slope and a point, then I'm going to pick point-slope form. Because, you know, that accepts these ingredients. You know, these are the perfect ingredients for this formula, because now I can plug in -3/4 for the m. The 8 is going to go in for x1, and the -5 is going to go in for y1. So y minus, and then y1 is a -5. So yeah, it's y minus -5. There's a minus built into the formula, and then this y sub 1 turned out to be a negative number. So now, I know I'm getting a little ahead of myself, but in a second, I'm just going to write this as y plus 5, because minus -5 is the same as plus 5. M was given to me for free, which was that. And then I'm not plugging in anything for x. And then the minus, and then x1, which was 8. All right? Now, listen carefully. Well, how about I write it really quick? Just make that a plus. Oh, it was a negative, you idiot. -3/4, and then x minus 8. Now, listen carefully to what I'm going to say next, okay? Once you get your slope and your point plugged in to the point slope form, I mean, you have an equation. It's a good, valid linear equation, and with the directions not really asking, like right here, this just says find the equation of the line. They didn't specify how the equation should look. So, I mean, basically, according to the directions, if you were just going to kind of take the directions verbatim, you can stop right here. Because it's not like y plus 5 equals negative 3/4 times the quantity x minus 8. It's not like that's not an equation. It's an equation. But at the same time, I want to tell you that it's way, 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 way more common for like your final answer to not stay in this form. Like we're actually, it's very common to like end your problem in that form, slope-intercept form. And so all we have to do that is we first distribute the negative 3/4. So first we clear the bubble. Okay, so y plus 5 equals, okay, now negative 3/4 times x is just negative 3/4 x, no mysteries there. And then when you do negative 3/4 times also the negative 8, negative times a negative is a positive, and then we are going to get 6, I believe. I'm not going to take time now to go into a whole lesson on fractions right now. If you need to double check on your calculator, double check on your calculator, but negative 3/4 times negative 8 should be positive 6. And then the only other thing to do is to subtract 5 to both sides. And maybe I'll just go up here. And so y will be by itself, which, listen gang, that's essentially what slope-intercept form is. You know, slope-intercept form is basically when the y is isolated on the left side all by itself. And so by subtracting 5 to the other side, I've now gotten y by itself. And I can subtract the 5 from the 6 and get 1. And so, again, according, like, our very, very, very vague directions meant we should be able to stop there. And that, because that is a linear equation for this m and this point. But they're pretty much very, very often either going to straight up ask you for this form, or you're going to be taking like a multiple choice exam where none of your choices look exactly like this, but one of your choices looks exactly like that. And one final note about this form versus this form. Let's say they did blatantly ask in the directions, find the slope-intercept form equation of the line. That doesn't mean you have to start with this form. A lot of people get tripped up by that. You know, the directions ask for slope-intercept form, and so people start like this. You know? Sorry, I don't like that being in yellow. Let's make it purple. So anyway, as I was saying, the directions would have asked specifically for slope-intercept form, and so students start with that, and then they get lost maybe because they don't know how to use that as an equation making formula all the time. So again, like, you would start with this form, and just make sure you end in that form. Just because they ask for this form doesn't mean you have to start your work with this form. You can start with this and just make sure you end with that. All right, now a few examples like this where, oh man, they didn't give me the perfect ingredients. I mean, they did give us a point, but instead of giving us the slope for free, they just gave us, another point. So they gave us 2 points, which, what do we do with that? I mean, if we're going to use this formula to make an equation, we need a point and we need m. So what are we going to do? Well, it's actually not that complicated. Since we need m, and you can find m with 2 points, that's what we're going to have to do first. So we're going to use another classic formula that'll end up on your Keystone formula sheet, and we're just going to take these 2 points and figure out the slope ourselves. Off to the side, we have to do a little bit of side scratch work first because we're not going to be able to plug in for m until we know what m is. And so let's just do that really quick. It's not like it's a big mystery to us. It's not like we've never done this before, taken 2 points and taken those coordinates of the 2 points and figured out the slope. So y2 minus y1 right there, and then we're going to do on the bottom x2 minus x1. Oop, stupid board. Minus 1. So is this correct? So we got 1 minus 9, check. Negative 1, okay, so this should be right. And so 1 minus 9 is negative 8. Negative 1 minus 3 is negative 4. And so this cleans up, divides clean actually, to just be a positive 2. All right, so I guess what I'm going to be plugging in for m is positive 2. And as far as x1, y1 goes, here's a little secret. You could use the coordinates from either point. All we needed, we have 2 points. You could use either one. But why don't we just use, the x and the y that, that we literally just got done calling x1 and y1. So I'm going to use this and this again because we just got done calling that, labeling that x1 and y1. So it looks like I'm going to be plugging in 9 for my y1, and I had to figure out that m was 2, and I'm going to be using 3 for my x1. And again, depending on the directions and things like that, you could potentially stop right now. You have an equation, but more often than not, we probably want to take this form and clear the bubble on the right side by distributing the 2. And so we get to there, and then we're going to add 9 to the other side to get y by itself. And negative 6 plus 9 is positive 3. So I'm going to have my final answer be that, which ends up being in slope-intercept form. Another example, which I would encourage you now to pause the video and try this example on your own first, and then unpause it to see how, what the final answer I got for it. So I'm going to start in 3, 2, 1, and here I go. So obviously the first thing I need is my m, and so that's going to be -3 minus a -5. And then on the bottom it's going to be 12 minus 4. And so -3 minus a -5, that's like doing -3 plus 5. So that's 2. 12 minus 4 is 8. And so this cleans up and reduces to 1/4. Remember, slope usually pretty much all the time should be a fraction, not a decimal. And so now that I know what m is, I have what I need to plug in to my point slope form. So once again, I just got done calling this my x1 and this my y1. Even though I could now just go with the 12 and the -3, I'm going to just stick with, let's see, -5 was my y1. I had to figure out that my m was 1/4. And then my x1, I'm sticking with 4. And again, this is like the third time I'm saying this, I think. You don't plug in anything for the regular x and the regular y. And so I'm going to make this into just +5. And at the same time, in the same step, I'm going to distribute the 1/4. So 1/4 times x is just 1/4 x. And then 1/4 times -4 ends up being -1. And now the last thing I got to do is subtract 5 so that y can be by itself. And then -1 minus 5 ends up being -6. So that's what I got for my final answer. Y equals 1/4 x minus 6. And I'll use this moment right now just to kind of say, like, on a side note, could you, like, because we've been doing this recently, right? If you had a nice piece of graph paper, could you just plot these 2 points, connect them with a very straight line, like you probably want to use like a ruler and stuff, and see if you could like just eyeball the line that you drew to figure out what the m is, maybe count off your slope, your rise and your run, and then see if you could eyeball where your line was crossing the y-axis, which it should have been crossing at -6, and come up with the equation that way. Yeah, you could do that. That'd be like a graphing method, But that is not quite as consistently reliable as formula work like this, because maybe your grid isn't big enough for 12, -3. What if this was like 120, -3? What are you going to do then? You don't have graph paper that big. You don't have paper that big. And what if these were like really nasty coordinates, like 12.7, -3.25, or whatever? Or like, let's say your y-intercept like definitely wasn't hitting a nice whole number or integer number. What would you do then? So anyway, it's definitely not a horrible method to like just graph these points and see if you can come up with the equation that way, but way more reliable to go with like an algebraic analytic formula way. Like this. Same request. You should pause the video and try this on your own and then unpause and see what I get. Okay, so 3, 2, 1. Here I go. Like, just like before. Same thing over and over. We're going to have to figure out m on our own first, but again, it's totally easy to do that if you have 2 points. So -1 minus 5, that's y2 minus y1, and then on the bottom we got x2 minus 5. So negative 1 minus 5 is negative 6. 10 minus minus 5 is 15. That's right, 15. And this reduces to negative 2/5, I do declare. Yep, let's go with it. And now I can plug in to my awesome point slope form. So my y1 I'm going with is 5. The m I just figured out was negative 2/5. And my x1 is minus 5. So this says x minus minus 5, which, you know, if you're like super heads up, normally I'm pretty heads up. And I would have like immediately just made it x plus 5, because minus minus 5 is plus 5. Now let's distribute to clear the bubble. Negative 2/5 times x is negative 2/5 x. And then negative 2/5 times positive 5 should be negative 2, I do declare. And then when we add 5 to both sides, we're going to get negative 2 plus 5 is plus 3. And that's where I'm going to stop, you know. And that's all there is to section 4.4, people.